It's Kevin here with another science video, and today we're going to actually be talking about the Thomas Young double slit experiment, which was pretty fundamental in the beginnings of quantum mechanics and everything like that. And I wanted to do a video based on this equation right here because really there's nowhere on the internet that you can find the frequency or the wavelength of light. Let's say you have your own laser. I have a few lasers, and I've always kind of wondered what the wavelength was for them. But using this equation here and a really cool homemade trick, you can do your own double slit experiment. So just real quick, as you put light through a double slit here, it's going to create an interference pattern of constructive and deconstructive interference, and it'll create these dark and light bands. And there's an equation here where you can use sine theta. If you're not good with trig or anything like that, you can actually use this equation right here to solve for lambda, which is going to be your wavelength. All your parameters over here, the slit distance, however, in millimeters or in meters, is going to be your d. Your delta x is going to be your distance between your slits here in your fringes, your light and dark patterns. And then your m is going to be your first order. Everything's going to happen from the center on out, so anything after that is going to be second order, third order, etc. And then obviously the length is going to be the distance between where you're standing to whatever you're projecting the screen on. And I'll show you. You can take any laser and you can actually use, to get your double slits, you can use 3 pencil leads. And this will actually create the same double slit interference pattern that you would see in really high-end and expensive experiments. So let me just show you over here how we can do this. We just evenly space the pencil lead. Normally I like to do it from short to long so that you can go up and down with your laser. And you just project it on something. And hopefully you can see that there's little light and dark patterns on there where you have the slit distance. And if not, you can just try this at home and you'll definitely be able to see it. May not come good up on the camera here. Okay, so a little tip for you guys, and I've already done this before, but if you stand a meter away and you're using the first order fringe distance here, it's just essentially going to null your denominator, make it equal to 1, so all you have to do is your numerator. The experiment that I did, it was 1 times 10 to the negative 4th meters for my slit distance here. Used a caliper in the physics department to measure that. And then my delta x, these were about 3 or so millimeters. So you just equal that up, and it came to 680 nanometers, which was the frequency of red light. So you can try this at home, and I hope you have fun.